Want to evaluate this indefinite integral. This is going to be a challenging one. We're going to need to let this part right here be u. So u is the square root of 7x. Now I'm going to rewrite that as square root of 7 square root of x, just to see those separate. And in fact, that x, I'm going to make that x, the root x, I'll make that x to the half power. Okay. And so then the derivative du dx is bring down the half. So it's root 7 over 2. Subtract 1 from the power to the minus 1 half. Multiply both sides by dx, cancels. So du is root 7 over 2, x to the minus a half dx. Okay, so let me get a little more room there. So du is root 7 over 2, x to the minus a half dx. Okay, and so now I'm going to take this function right here. Let me bring it right here, and I'm gonna rewrite. I'm gonna get rid of all the stuff I can. So it's going to be 19 to the u power over, and that bottom I'm going to write root 7 root x separate, kind of like I did in the other plot spot. So I just took this, and that root 7x up there, that's become u. Okay. And this root 7, I'm going to move here, and then I'm going to rewrite this. So this is the 1 over the root 7 of the integral of 19 to the u power. Oh, in fact, actually, let me do this. Let me make it 19 to the u power times x to the minus a half dx. Because that's what a root x in the bottom is x to the minus half, right? Now, why am I into that? Well, because here we have, because I got to get rid of this x stuff. Here's x, got to make it all u, right? Here's x to the minus half dx. So there's what I need right there. Let me just multiply top and bottom. 2 over root 7 cancels that out. What I do to one side, do to the other. So 2 over root 7 du is x to the minus a half dx, right? So wherever I see x to the minus half dx, I can replace it with 2 over root 7 du. So this right here is 2 over root 7 du. So this integral becomes 1 over root 7 integral of 19 to the u times 2 over root 7 du. Now we have it all in terms of u. It's all u. There's no more x in there. So let me grab this and move it to the front. So that'll be on the top, 1 times 2 be 2 on the bottom. Root 7 that was already there, the other root 7, right? Just grab that, bring it to the front. And then we have the integral of 19 to the u du. Okay, well, how do we do this? Oh, by the way, this denominator is just going to become 7, right? Because it's root 49, which is plane 7. So I'll just get rid of that. Well, so on the next line, I'll just, okay, so that's 2 7s. And then I got to do the anti, let me move it down a little bit. Going to be 2 7s. And I got to do the antiderivative, because that's what these operators are saying, the integral and the du, do the antiderivative on 19 to the u. So how do you do that? What's the antiderivative of that? Well, coming up here I wrote out some of the rules just to refresh your memory. When x is in the base, that's not what we have here, but when you have x in the base, that's easy derivative rules, right? That's just the power rule. Just bring down the 10, subtract 1 from the power, 10x to the ninth, no big deal. But when x is in the power zone, like e to the x, 10 to the x, 8 is x is in the exponent zone. We call that an exponential function. X is in power instead of just in the base. That's a different set of rules. Those are called exponential. Derivative e to the x, that's our favorite one. He does nothing. Derivative 10 to the x, he almost does nothing, but then a little ln 10, it multiplies by an ln 10 because it wasn't the perfect e number. Same thing with a to the x, the derivative does nothing, but then you multiply by the ln of a. So you multiply by the ln of a for the derivative. Therefore, for the antiderivative, the opposite, you're going to divide by the ln of a for an exponential function. And that's what we have here. This is exponential, meaning the letter, the u, the x, the whatever, the letter's up in the power zone. So the antiderivative of that, we're going to divide by the ln of that base, like that, times 19 to the u. Right? So in general, it does nothing, but then you got to divide by the ln of the base. That's the antiderivative. So there it is. There's basically our answer. We're just going to go 2 over 7 ln 19. Just put those together. Times 19 to the u. And what is u? What was u from the beginning? U was root 7x from the beginning. U was root 7x. All good. And there it is. We did it. Is that the answer there? So 2 over 7 ln 19. 2 over 7 ln 19, 19 to the root 7x, and they put in the constant for us. And so there we go.